Hello friends, welcome back. This is review 3. Let's begin. I want you people to recall what and all we have learned from the beginning till now. This is a review where we are going to see everything from the beginning to till now little bit faster. Let's begin. What we have done, we have learned in the beginning how to create a Unity project. Unity is a physics engine which helps us to create simulations and games. And behind the scene it uses .NET framework where we have a C# programming language. We use that to make games or simulations or implement behaviors. We have seen how do we create a Unity project, and when we are creating a Unity project we will be giving the name of the project and the location to be stored, whether it's a 2D or 3D. Then we create a Unity project. Once we create a Unity project, we have seen how do we open already created project, right? And we have seen the folder structure. There are 4 important folders in the Unity project, right? Assets, library, and what else? Library, assets, project settings, and the temp folder. And temp is the one which is going to be created temporarily at the time of project execution, right? Or when we will be working with project, temp is going to be created, and when we are not working, the temp folder is going to be removed, right? It's a temporary location or where intermediate files are going to be generated. And the library is the one which is going to hold the different libraries that we are using in the project. Assets is going to contain all the assets, game assets like images, video, audios, 3D models, then scripts, a lot of things. Then after that we have seen how do we create a C# script and how the C# script is attached to a game object, like we have attached to the main camera, and we got an idea how the C# script going to get executed, right? First, like at the scene, in the scene, the controller will see the scene. In that, the first object we have is a main camera. It goes to the main camera. To the main camera, we have attached one script, and it start executing that script. In that script, we have a start function, which is the one start getting executed, right? And we have seen a smallest code, that is debug.log. How do we display a hello world? We started with a 1-line code. How a hello world is going to be displayed, or hello Unity is going to be displayed on the console window. At that time we have seen the levels, not levels, what we say, layouts. Yeah, the layouts, different layouts used by the programmers and the designers. And there we have seen different panels, like a hierarchy panel. There we are going to see the list of game objects which are present in the current scene. And the scene is the panel where we are going to create our game, and the game is the panel where we are going to see the output, and the camera preview window where we are going to see how the game looks through the camera. Then we have seen a console window where we will get the text outputs. We can log there, and we get error messages, warnings, everything we can see there on the console window. Then we have seen inspector panel. Inspector panel is used to inspect or see the properties of a specific selected object, right? Then we have seen Unity debugger, right? We have seen how to attach a debugger and debug the code step by step. If we are getting any unexpected outputs, then how do we analyze it, right? By using the breakpoints. And we have used, there we have seen the different panels like locals, where we will find the local variables of a function. And we have seen call stack. Call stack is the one which is going to keep track of function calls. Then we have went to the assembly browser, right? That is the assembly browser, which helps us to find out which class is present in which namespace, which method is present in which class, or the namespace, what are the classes and structures or events or delegates present in the namespace. You can say that hierarchy of the assembly. There are 2 different assemblies .NET has or Microsoft has, like DLL and exe file. Dynamic link libraries are assembly files which cannot be executed by themselves. They need to take a help of Another files that are executable files, which are self-executable. If you double click on the exe file, it just gets executed. We have seen a MonoBehaviour class, which is going to be inherited by many classes in our games. And the MonoBehaviour class is one of the most important class, which is present in the Unity engine namespace. That is the reason at the top we write using Unity engine namespace. And the MonoBehaviour is the one has a start function that we are going to override in our class, and the start is a function which is going to get executed in the beginning. Cool. Then the MonoBehaviour class is inherited from the composite class, and the composite class is inherited from the component class. Component class is inherited from the object class, right? Object is the mother of all, the super mother of all the classes, you can say. So in C# everything is object. So C# is an object oriented programming language. Then we have seen tokens of C# like KixOS, CKixOS, comments. We have seen 3 different types of comments: single line comment, multi-line comment, and documentation comment. And comments are ignored by the compilers. They are used for understanding purpose. We have seen there how do we write comments. Then come to keywords. We have seen that keywords are the reserved words. Their meaning is already written in the compiler. You cannot change their meaning. You cannot use the keywords as the name of an identifier. There are more than 87 keywords are there in C#. For example, int, float, char, double, if, while, these are all keywords which are written in a small letters. Then we have data types, right? Then we come to data types. Data types indicates what type of data, what's the size of data to be allocated, and what are the operations that you can perform on the data. When we came to data types, we have seen there are 2 types of data types mainly: primary data types or primitive data types, and non-primitive data types. Primitive data types are also called as basic data types that are available in the C# language, and non-primitive are derived data types which you will create by using the primitive types. In primitive types, we have again 2 different types: value types and reference types. Value types, we have seen the difference between value types and the reference type. Value types hold the actual value, whereas the reference types hold the address of another memory locations. When you come to value types, we have seen again 2 different types: numeric type and non-numeric types. Numeric types means which hold numbers. Non-numeric types cannot hold numbers. That's all, right? In numeric types, we have seen 2 different types: integers and real numbers. Integers are those numbers which hold only the whole numbers, whereas real numbers are going to hold the decimal numbers or floating point numbers or rational numbers, fractions. Now integers are divided into 4 main types, like a byte, short, int, and long. Byte is 1 byte, short is 2 byte, int is 4 byte, long is 8 byte. And all these 4 types are signed data types. We have unsigned data types also, which can take only positive values. They are ushort, uint, and ulong. Even byte is also a unsigned data type. And we know the range of data that each type will hold. And real data types are float, double, and decimal. Float is a 4 byte, double is 8 bytes, and decimal is 16 bytes. And we know that float is a single precision which can hold 0 to 7 digits after the dot or decimal point, whereas double, which holds 15 to 16, and the decimal will hold 27 to 28 digits after the decimal point. So if you need higher accuracy, you can use the decimal. If you want least accuracy, then you can use float, when accuracy not matters much. Then we have seen non-numeric types like character and the boolean. Boolean takes only 2 values, true or false, and character takes a single character. And we have a C# supports Unicode character set and ASCII character set. ASCII stands for American Standard Codes for Information Interchange, and Unicode stands for Unified Character, Universal Characters. That ASCII is a 7-bit, so you can represent 2 raised to the power of 7 characters, which is equal to almost 128 characters you can represent. Whereas Unicode is a 16-bit character set, so using that you can represent 65,536 characters. So very huge number of characters you can represent by using the Unicode character set. Unicode characters usually we represent by using the /u character. And Boolean takes only two values, true or false, which is of 1 byte size. After that, we have seen the reference types like an object. We have seen boxing and unboxing, right? Putting a value type into a reference is called boxing or wrapping, we say. Unboxing means taking out a value type from the reference type is known as unboxing. Then we have seen strings. Strings are usually we represent strings in a double quotation. Anything you put in a double quotation is going to be treated as a string. After that, we have seen non-primitive or derived types, like we have built-in non-primitive types which are arrays and pointers. We have user-defined derived types. User-defined means user can create his own types, like using structures, class, enumerations. User can create his own derived types or types which he can use to create variables or constants later. That is about data types. And while learning data types, we have seen if we have a mixed mode data types, which data type will win. We have seen typecasting like conversion and coercion. Conversion means explicit typecasting. Coercion means implicit type conversion. Implicit conversion will be done by the system itself, that is, smaller the size will be moved easily without any problem to the higher size data type. Whereas if you want to do in the reverse direction, you have to do explicitly. Explicit conversion if you are doing, you have to take care of whether you are losing the data or losing some precision. That is most important. After learning the data types, we have got an idea about identifiers. So what is an identifier? Identifier is a sequence of symbols which help you to identify the specific part of a code, right? Now identifiers are maybe a name of a variable, name of a class, name of a function, name of a namespace, name of an enumerator, or event, or a delegate. All these names are written by the users. And when we name the variables or constants or functions, we follow some rules. There should not be any space. You can use one underscore. You will not be having any other special characters you cannot use in naming the identifiers except the underscore. While naming variables, we use camel case, and while naming the functions, class, and namespaces, we use Pascal case. That is really good. And while naming the constant, we use all the letters capital. And if we have more than one word, then we use underscore to separate one word with another word. And we have seen there should not be any space in between the words while naming. Then we have seen constants and variables. Variables are the named memory locations whose value may change during the execution of the program. And we have seen before you want to use a variable, you have to initialize it. How to declare a variable we have seen. How to initialize a variable we have seen. We have seen how to declare a constant. We use a const keyword. Then we have seen constant must and should be initialized in the beginning. Then after that we come to characters and strings. We got an idea about characters and strings. Then we went to the operators. So while learning operators, we have seen that an expression means a valid combination of operators and operands which give a result. There are different types of operators we have which are helpful to do operation on specific type of data. Larabix is a shortcut that we have used. L for logical operator, A for arithmetic operator, R for relational operator, A for assignment operator. While seeing assignment operators, we have also seen shorthand assignment operators. Then we have seen bitwise operators, bitwise shift operators, increment, decrement, conditional, and special operators. Logical operators are used to do logical. First we have seen arithmetic operators, right? Plus, minus, multiplication, division, and mod. Now plus minus we use to add or subtract. If you want to change the sign of a number, we will be using the minus operator. Then we use multiplication operator to reduce, scale something or descale something. We use multiplication and division operator. And the mod operator is used to lock the numbers. If I want to get a series, something like 0, 1, 2, 0, 1, 2, 0, 1, 2, I'll be using mod 3 to lock, right? And yeah, we have seen that division and mod are really useful operators in making levels or tile maps or frame-based animations. And the multiplication operator to reduce something by a percentage, very useful operators. Then after that we have seen relational operators, are also called as conditional operators, used to check check the conditions, right? Yeah. Then there are 6 relational operators, which are less than, greater than, less than or equal to, greater than or equal to, double equal to, not equal to. Whereas arithmetic operators are 5. And we have seen the logical operators. They are also called as connectives, like logical and, logical or, logical not, right? We have seen their truth tables. Then we have seen assignment operator, which is equal to sign. And also we have seen shorthand assignment operators like plus equal to, minus equal to, multiplication equal to, division equal to, how they are useful. Right? Assignment operator is used for initialization purpose. Then we have seen bitwise operators. If I want to work with bits, we will be using bitwise operators. We have seen bitwise and, bitwise or, bitwise complement, and we have seen bitwise exclusive or and their truth tables. Then we have seen bitwise shift operators, left shift and right shift. And while learning bitwise left shift and right shift, we have seen what happens actually behind the scene, right? We have seen their calculations, like multiplication sign we use when we are doing a left shift, and the division operator we use for right shift. Then we have seen increment and decrement, that is plus plus and minus minus. And increment and decrement operators are used to increment by 1 and decrement by 1. And we have seen how the increment and decrement operators are used. In for loop we have seen the conditional operator is a question mark colon, which is the only one ternary operator, right? It is an alternative for if-else statement we have seen. Then after that we have seen a special operators. Few special operators we have seen, like size of operator, which gives us a size of any data in bytes. Then we have seen in operator, which we use in a for each loop. And we have seen new operator, which helps us to create new memory locations on the heap used to call the constructors. While learning operators, we have seen precedence of operators. So precedence and associativity is one of the most important part. Precedence stands for which operator to be evaluated first if we have a mixed mode operation. Associativity means whether we have to evaluate the operators from left to right or right to left when we have same operators in one expression. We have seen BLCAC, BLCAC, a shortcut, and unary operator and conditional operator and assignment operators are of right to left associativity. All others are left to right. Then after that we have seen how to convert some mathematical and physics expressions to code, what we need to concentrate there, how precedence and associativity are important parts of converting a math to code or expressions to code. Then we have seen mathf structure, which is a very useful structure where we are going to find different mathematical functions which helps us to do mathematical operations very easily. And F stands for float. This math class or a structure takes float values and returns the float values back. Math F. That's the reason they have written F. And I hope you remember, if you are working with floats, we will be using a successor F. If I want to represent a long number, we will be using a successor L. If I have to represent a double, we use D. And if I have to represent a decimal number, we will be having a successor M. Then we have seen a string class, which is a very useful class to do operations on string data type. We have seen 2 lowercase, 2 uppercase, compare, equals, right? There are many different functions available in the string class. We have seen the length property, which gives us total number of characters in the string. All the many math functions are having static functions. If you have to access those functions, you need to write the name of the class, that is mathf, put a dot, and then access the function, right? Then after that, we have seen control statements. If you have to control the flow of execution of the program according to my requirement, I'll be using control statements. Control statements are divided into mainly 3 parts: conditional statements, looping statements, and jumping statements. Now conditional statements are if else, else if ladder, switch case, and nested if else. We have seen that if else, else if ladder, and nested if else, we will be using if we have any condition. Based on the condition, if we want to execute some part of a code and skip some part of a code, we will be using these statements. And switch case we use when a single variable has more than one alternative values, we will be using switch case. We have seen the use of switch case in many places till now, right guys? Then we have seen the looping statements: for loop, while loop, do while, and for each. For loop and while loop are entry control loops, and even for each also an entry control loop, we can say. Now for loop and while loop, we know when to use a for loop and while loop, right? When we have to use a for loop, when we know how many number of times the loop has to get executed, we use for loop. When we don't know how many number of times the loop is going to get executed, we use while loop. And we use do while loop when we want to execute some set of statements at least once, whether the condition is true or false. And for each loop we use with arrays or collections. We have already seen, and we have seen for loop, a reverse for loop. We have seen there is a linear for loop. If we have only one for loop, we say it as a linear, whereas quadratic for loop means one for loop inside another for loop, where the size of outer for loop is n, inner for loop is n, then it is going to take order of n square time to get executed. Then we have seen dependent quadratic loop. That means the if inner loop is dependent on outer for loop or outer loop's variable value, is called as a dependent quadratic loop, which will take n into n plus 1 divided by 2 order, right? Then we have seen jumping statements like break and continue, return and go to. As we know that, I'm not going to explain go to. We have seen break statement and continue statement. We use break statement when we are working with switch case and the loops. Break statement is used to skip some part of the code and just come out of the nearest block, right? Nearest loop. Break is very useful code. Let us take, we have seen an example that whether the number is prime or not. If a number is prime, we just set the break and we will not further proceed the loop. We just come out of the loop, right? Whereas continue is the one which is used to skip some part of the code and continue the loop. We use continue keyword. Return we use in functions that we will see soon. Then after that we have seen arrays. Now what is array? Array is a homogeneous collection of data elements. That means it is going to hold only similar type of data. Arrays are actually referenced type. That means an array variable holds the address of another memory location, a collection of memory locations, right? Each element in the array is of similar type, similar size, and they are contiguous, means every memory location is contiguous, sequentially arranged one after the another. Each variable in an array is actually known as indexed variable because arrays are going to be indexed. They start with an index 0 and end with index that is size -1. Arrays are static in nature. That means you cannot increase the size of an array or decrease the size of an array at runtime. Dynamically you cannot change. Okay, at compile time you are going to fix the size of an array. Okay, once you assign the size to an array, it will not change. After that we have seen the difference between the value type and reference types. Then we got an idea that arrays are instances of system.array class. Array is a class which is present in the system namespace of the unit C#. Then we got some idea about stack and heap. Stack is a fixed size, heap is not fixed, and heap is the dynamic, right? Stacks are used to keep track of function calls, and heap is a place where we will create dynamically memory locations and deallocate them, allocate and deallocate the memory locations dynamically on the heap. We have seen there the memory leak problem. If you are creating the memory location using the new operator, it is your responsibility to remove. But as we know that C# is a managed programming language, it's a memory managed. Why it is called memory managed? Because it has a garbage collector. A garbage collector is the one which collects all the garbages which are not used. Whereas we know that C++ is not memory managed because it has no garbage collector. There you are going to find a memory leak because as a C++ programmer we have seen that if we are allocating the memory location on the heap using a new keyword, we have to deallocate by using the delete keyword. Otherwise, that memory will be always available there or always allocated in the heap, which will not be available for reuse until it is removed. Okay guys, that is about the garbage collection. Then we have seen a new keywords like in we use in a for each. New keyword which is used to allocate the memory location. In is the one which is, you can say that whether there is a next element in the collection. Whether there is a next element in the collection, we use the in keyword. Then length is the property which returns the total number of elements in the array. We have seen a function called as getLength where we pass 0 which gives the total number of rows. GetLength of 1 returns the total number of columns in a two-dimensional array, right? Then we have seen there are different types of arrays, 1D, 2D, 3D, or even you have 4D, multi-dimensional arrays, we can say. 1D indicates either a row or a column. 2D indicates a table, which is a collection of rows and columns. Whereas 3D is a cube. And we have seen how to declare, how to initialize and access them in different ways. And we have seen the importance of precedence of operators again in that place when we are creating the levels or maps. Then we have seen operations on arrays. What are the operations that we can perform on arrays? Are we can traverse an array in forward direction by using the for loop, in the reverse direction by using reverse for loop, and we have seen for each loop how it is useful. And for each loop is only forward loop. You cannot, it has a limitation, right? You cannot do a reverse for each loop. Then we have seen how searching is useful. We have done a linear search. I told you that learn binary search. Then we have seen how do we swap two variables and swap two arrays also. And we have seen sorting of arrays, how it is useful to arrange the elements in ascending or descending order by using exchange sort or a bubble sort. There are different types of sorting techniques like insertion sort, quick sort, merge sort. You can try them by yourself. If possible, I will explain later. Then sum of elements, how do we add all the elements in the array? We have seen how arrays are useful in performing matrix operations like addition of matrix we have seen, and I told you to try matrix multiplication by yourself and understand how it works. If you do not understand, please let me know. Definitely I will help you out. After that, we have seen use of switch case and else if ladder, right? How they are useful. We can use instead of else if ladder, we can use switch case also. Then we have seen applications of arrays like storing the list of elements and processing them. We use usually arrays if they are static. There is a list of static elements or static list of elements. Then we have seen that arrays are useful in creating tile maps or level designing and much more. This is the review 3. I hope you guys have understood whatever I have explained and you have recalled. I have explained more than this. Okay, whatever I have at present in my mind, I just reviewed. Hope you guys are enjoying the tutorials and learning a lot of things step by step. Improve your skill, keep learning, keep coding. Okay guys, thank you very much. See you in the next tutorial.